It's a bird! It's a plane! Wait, what is that thing? That, my friend, is a tardigrade. Teeny tiny superheroes of the animal kingdom. Their superpower is invulnerability. They've been boiled alive. They've been frozen to within 1 degree at absolute zero. They've been shot into space without a spacesuit. Yet, they survive. They might even have a base on the moon. Not kidding. A spaceship full of them once crashed on the moon, and scientists aren't 100% sure that they all died. Tardigrades are about as close to invincible as any life that we know of, and these tiny but mighty superheroes are helping us fight one of humanity's biggest villains: infectious diseases. A staggering amount of lives have been lost to this arch-nemesis. Fortunately, we have its kryptonite: vaccines. With the help of vaccines, around 6 million lives are saved each year. Unfortunately, disease is a henchman: inadequate infrastructure. Vaccines aren't available equally around the world. They are fragile and need to stay far below room temperature at all times in order to be effective. In regions without the energy resources to keep vaccines refrigerated continuously, even when being transported, vaccines go bad before residents are able to access them. To understand how tardigrades can help, we first need to look at what happens inside animal cells whenever they get dehydrated or too hot. When normal cells undergo stress like dehydration, they begin to shrink and deform, causing mechanical stress and instability of cellular materials like proteins. Intracellular proteins can also be affected by thermal stress like heat, which adds kinetic energy and causes the molecules to vibrate. Either of these stresses can cause proteins to unfold or denaturate. This is bad because a protein's three-dimensional structure is essential to its function. It's like a key. If it melts, it doesn't work. Vaccines often use proteins from pathogens to invigorate our immune systems, so protecting these proteins from changing moisture levels and temperature fluctuation is important. Here's where our tiny superstars come in. Tardigrade cells aren't like normal cells. When our heroes are under stress, they begin to dehydrate, but instead of dying, they go into what's known as a ton state. Their metabolism drops to 0.01% of normal function. While in ton state, it's almost impossible to tell if they are alive, but tardigrades can reanimate after more than 30 years of looking dead. How do they keep their cells from turning to mush? They produce a unique set of proteins called cytosolic abundant heat-soluble or Cas proteins. These are intrinsically disordered proteins, meaning they aren't confined to a single shape like other proteins. Under stress, they surround other parts of the cell and hold them in place, keeping them from shifting around. Essentially, it's a suspended animation gel. Tardigrades are the only animal to produce Cas proteins naturally, but fortunately, bacteria can duplicate Cas proteins in labs. Studies have found these proteins to potentially be 10 times more effective than current FDA vaccine protectants. So thank you, tardigrades. The hospitals of Metropolis are forever in your debt.